Hello guys. I hope you're good. Also good. Anyway, let's quickly continue with our lessons like always. So today we'll be discussing integrals involving inverse trigonometric functions. So what we're doing is that will be given. So here, let me just remind you of differentiation of inverse trigonometric functions before we go to the integrals of them. Okay, so in differentiation, we would sometimes differentiate sine inverse of f of x, and then that will become f prime of x divided by 1 minus f of x squared. Let's take for example it's what it's sine inverse of, let's take for example it was dx of sine inverse of x. So then the answer for this will then become just 1 divided by square root of 1 minus x squared. So in integration, you'll be given this answer and then they say find this, you understand? So it's more like we'll be given this, now we'll have to go back to that, because in differentiation we're going to this, now in integration we go back to that. So that's what we'll be discussing, meaning that what is this? In integration we'll be given these answers, all of these answers. So the answers won't be directly in this format. Sometimes you need to force your answers to be in this format so that you can then conclude that if it's this format, then it was tan inverse of whatever that argument that you'll be dealing with, so that you get back to this. You understand what I'm trying to say? I hope you do. So what I'm trying to say, let me just say you'll be given something like this, dx. So when you need to then conclude that this is this, you understand? Because in integration we go back to what was differentiated, you understand? So this is what we'll be dealing with for today. So everything, so you must have crammed all of these formats. So for sine inverse, cos inverse, tan inverse, cot inverse, sec inverse, and also cosec inverse, you must have crammed all of these formats. So I'll be showing you how to go through these different type of questions involving all of these formulas. So yeah, stay tuned. For example, before you forget, so let's again just do this one. So you can see here now we're given the integral of 3 upon square root of 1 minus x squared dx. So when we see this shape of 1 minus x squared is it's which one? It's this one of sine, right? It's this one of sine because of on our denominator here we have 1 minus f of x squared. So again we can just rewrite it nicely so that everyone can see. So I can just take out the 3 outside, so I can just take out the 3. So when I take out the 3, I'll end up having the integral of 1 the x divided by square root of 1 minus x squared, just like this. So you can see that, because look at this this shape. This formula says that we should have what? We should have f of x and the derivative of f prime of x there on our numerator. So in this case, if we let x to be the derivative, if we let x to be f of x, then this has to be the derivative of this. So when we check, the derivative of x is 1, so meaning that yes, now we can then conclude that this is equivalent to sine inverse of this x, you understand? So then now you just come to your answer now and say, so you must take out the 3 here. This 3 must go to the answer, so it's going to be 3 sine inverse of x plus c. Then ta-da, you have your answer. So simple as that. You just need to make sure that you have the format that aligns with one of the formulas there, and then you conclude, you make a conclusion based on that. So sometimes there are cases whereby our a there is not equivalent to 1. So meaning that A could be something else, could be 4, 3, whatever number except for 1. You understand? So we need to then make use of these formulas. If not, if you don't want to make use of these formulas, then you can then what is this? Let me see. If you don't wanna make use of this formulas, okay, I'll explain. I'll explain with the use of equation. For now, I'll just do an example whereby I'm explaining when A is not equals to 1. Because look at this case. With the example that I've just solved, our A here was equivalent to 1. You understand? Because here we have 1 squared, so meaning that A is equivalent to 1. So these ones are straightforward. But even these ones that we're about to do, they're also straightforward. It's just that you need to make sure that now you have A squared. You'll see how I'm gonna do it. So these are the formulas that we're gonna use when we have integral of f prime of x divided by a squared minus f of x squared. We then say this is equivalent to sine inverse of f of x divided by a. What you need to make sure that you must have the derivative on your numerator. You must have the derivative of what's here. You understand? So that's it, and then you just force everything to be you just make use of this formula with regards to what kind of shape or format do you have here on your left hand side or inside your integral or in your integrand. So yeah, here's one example. So in this example, let's then rewrite this in a nice way so that we can see it fits into which format, and then we'll then see. So here we have x squared divided by the square root of what is this, 4. So 16 is the same as 4 squared minus x cubed to the power of 2 dx. So when we check, remember on our numerator we must make sure that we always have the derivative of whatever that's here. You understand? Whatever that's here. So when we derivate x cubed, what do we get? We get 3x squared, right? So when we check on our numerator, we only have x squared. So we can conclude that this integral is equivalent to something that's here, without having to make sure first that on the numerator here we must have the derivative of the this thing that's here. So let's first make sure that we have the derivative of x cubed on our numerator. So the derivative of x cubed is 3x squared. So let's make sure we have 3x squared. But then we don't want to change our equation, so we can't just put 3 without having to cancel it. So let's cancel that 3 by multiplying by 1 over 3 outside the integral there. So 3 and 3 cancel out, so meaning that I still have the same thing there. I didn't change the equation, but then I can make use of this integral, that is the derivative of x cubed there on our numerator. So when we check this format of 4 squared minus this squared, and then we have the derivative of this there on our numerator, it's which one? It's the first one. It's the first one, right? It's the first one. So we need to then conclude that now this integral is equivalent, so this 1 over 3 must go to the answer as well. So it's going to be 1 over 3 sine inverse of this over a. So our a here is 4, because we must have a squared. So our a here for this case is going to be 4. So that's going to be x cubed over 4, and then plus c. And then that will be it for that one. So I hope you are seeing what's happening. I hope you are seeing what's happening for now. So what can I say now? So let's take you don't want to make use of what? You don't want to make use of these formulas, or somehow you forgot these formulas of 1 over a. So you want to make sure that here you have 1. So meaning that, so what does it mean? It means that you must take 4 out as a common denominator. So there could be or an or thing, yeah. So or one of you could have said, I want to use this method. So let me show you. So one of you could have said, I want to work with a being 1. You understand? I'm comfortable with a being equivalent to 1. So we're gonna take 16 as a common factor there. So this is going to be 16 into 1 minus x to the power of 6. So let me just say x to the power of 6, or x to the power, yeah, x to the power of 6 over 16, then the x. I hope you can see that. So I took out 16 as a common factor. So when you take out 16 as a common factor, you'll end up having okay, 16 that. So this and this are the same thing when you multiply back. I hope you all can see that this is the same thing. So from here you're going to split. So you're going to have you're going to make 16 to have its own radical sign, to have its own square root, and then 1 over 1 minus this to have its own square root as well. So meaning that from here we are going to say this is what this is. Okay, so this is going to be equivalent to x squared divided by square root of 16. So this is going to be square root of 16 multiplied by the square root of 1 minus x to the power of 6. So x to the power of 6 divided by 16. Then you also have your dx there. So square root of 16 is what? It's 1 over 4, right? So I mean, like, it's 4. So here we have 1 on the numerator. So that's why I'm saying 1 over 4. So yeah. And then we're going to take square root of 16 there outside the bracket. So we'll end up outside the integral. We'll end up having 1 over 4 into integral. We have x squared there, and then this x squared is divided by what? By that thing of 1 minus. So here we have got 1 minus. So we need to make sure that this is going to be x cubed over 4, so that I then square it. I hope you can see that x to the power 6 over 16 and x cubed over 4 are the same because I've squared this. You understand? Yeah, you do. Okay, I shouldn't forget my dx there. So from here, now that we have 1 here, we don't have to stress about 1 over a or something. You understand? So what do we then do? We then make sure that here on our what is this, on our numerator, we have the derivative of this. So when we derivate this, what do we get? We get 3 over 4, right? We get 3 over 4 here when we derivate this. So let me do this. All right. So when we derivate x cubed over 4, we get 3x squared over 4, right? 3x squared over 4. So here we must make sure on the numerator we have the derivative of this, right? So this is going to be 3x squared. So we already have the x squared. We're only left with the 3 over 4. So let me put 3. Let me put 3. So we already had the x squared. So let me put only the 3 over 4. You understand? So that this thing becomes the derivative of this. You understand, right? So, but then I didn't have 3 over 4. So I need to make sure that I cancel 3 over 4 by multiplying by 4 over 3. You understand? So then, so that 4 and 4 can cancel out, and 3 and 3 can cancel out, so that I still have the same question. I didn't change anything, right? Makes sense, right? So from here, what are we gonna do? We are then going to conclude that when we have this, when we have the derivative of this on our numerator, then we can then conclude that this format of 1 minus whatever squared is that one of sine. The first one, then let me go back to the formulas. This one, you remember this one, this shape of 1 minus this squared inside the square root, and then we have f prime of x there. Then this is sine inverse. You understand? So yeah. So here, outside the integral, 4 and 4, they cancel out, right? So you'll just be left with 1 over 3. You'll just be left with 1 over 3 multiplied by this one. So this one I've already discussed, and I just showed you the formulas, that this is going to be just sine inverse of x cubed over 4, and then plus c. Then ta-da, the two things becomes the same. So that is how to work when that's how to work with these things when now your a is not equivalent to 1, and now you want to force it to be equals to 1. So you then have to use this way. Makes sense, right? Yeah, I hope it does. I hope it does. So yeah, this is the same thing. So you decide which one you like between the two approaches. So you'll see which one you like. I like which one. I prefer both of them, but I'll see when it comes to questions which one I prefer the most, because I'll be using that one that I prefer the most, I guess. All right, we have another guy here. Let's see what we can do to him. Let's see what damage we can do to this guy. So now we need to integrate 1 over x, 9x squared minus 16. Okay, so now let's first do this one in a way by in which way? In that way whereby we treat it as we work with a squared, you understand? We don't work with a being 1, you understand? So let's work with that way whereby we have our, yeah, that, like I've said. So let's rewrite it nicely then to make sure that we have our a squared and our whatever squared. So this is going to be, okay, we have our dx here, and then on our numerator, okay, we have this x. On our denominator, we have this x, and then inside multiplied by the square root of, so 9x squared is the same as 3x squared, right? Minus 4 squared. So what? Again here we have 1 on our numerator there. So this is what we're given. I just tried to rewrite it nicely. So I said let's do this in 2 methods. The first one is to make sure that we work with a being equivalent to something else which is not 1, right? So to do that, we need to make sure that, okay, let me go back to the formula, or let me write down the formula here. I don't know, let me just go back to the formula. It's the same thing. So look, the question that we are trying to do, it's in this format, right? Because we have something here, we have f of x here, and we have f of x there, which is squared minus a squared, right? And we just need to make sure that we have f prime of x on our numerator. That makes sense, right? So is that then we can then conclude that this is equivalent to 1 over a sec inverse of f of x over a plus c. You understand? So before we conclude, we need to make sure that here we have f of x. So that means whatever thing that is squared here should be the same as this thing that is here, you understand? And then on our numerator, we should have the derivative of whatever that is squared here. Makes sense, right? So yeah. I don't know if I should, yeah, but you have seen the formula. I don't have to rewrite it. So according to that formula, we need to make sure that here we have the derivative of 3x, right? We have the derivative of 3x. So what's the derivative of 3x? It's going to be just 3. So I erase that 1 because it's a 1. Okay, what are we gonna do with 1? 1 is 1. We can just do anything to 1. So now I've put 3 there, and I know that 3 is not supposed to be there. So before I cancel it out, I don't stress about it. So another thing is that according to that formula, whatever that's here whatever that's squared here should be the same as that the thing that is here. So that means if here we have 3x, that means as well as here I should have 3x, you know. So this is going to be 3x as well, you understand? And then my 3 and 3, they cancel out, so I don't have to make something outside the integral here so that they cancel out these two 3's, because already these 3's are canceling each other. And on top of that, I can make use of them without having to cancel them, you understand? I can make use of this because this is then in this format, because now I have 3x, I have 3x squared, and now I have 3 here, which is the derivative of this, and I also have my a. Then I can then conclude that it is equivalent to 1 over a sec inverse of 3x over our a there, which is 4. 3x over 4 plus c. So yeah. So then from here we just write our answer. Then we just say our answer here is just going to be 1 over a. So 1 over a here is going to be 1 over 4. Our a is 4, so this is going to be 1 over 4 sec inverse of our f of x is 3x, so it's going to be 3x over 4. So this is going to be 3x over 4, then plus c. Ta-da! You have your answer. I hope this makes sense, right? It should make some sense. It should make sense. It should make sense. It should make sense. So that's just it. So what can I say? What can I say? So this one could be done in 3 ways, ne? I don't know if I should do the 3 ways or just 2 ways. Let me see. What do you think I should do? Now I should analyze your brain there. I think you are saying that I should do 2 ways, right? Let me just show you 2 ways. So there are people, I'm saying, the reason that I'm saying that this could be done in 3 ways is because of there are people that will prefer working with just x, yeah, you understand, so that we don't have so that we make sure that the derivative of this is just 1, since here we only have x. Okay, maybe I should just do 3 ways then. Let's see. Let's just do this in 3 ways. Yeah, let's just do this in 3 ways. Wow. This is gonna be a long one. I guess after this we're no longer doing this in a lot of methods. We just do one because I would have explained everything. So yeah. Okay, let's suffer just for this one, and then after that, so this is going to be method 2. Let me just do method 2. So method 2 here, let's rewrite this nicely then. So now we just need to we just want to work with only x. Yeah, you understand? We only want to have x. Yeah, we don't have a problem with having a squared, but then here we want to have a x because we already have x here. So we want to make sure that our f of x is also x here, because the x here, it's f of x. So f of x, we want to make sure that it's the same thing as here, you understand? So what we're gonna do is that we're gonna make sure that we have our 1 there, and then the x, and then here we'll still write that x, and then inside the radical sign or the square root, we're then going to take 9 as a common factor, and then after that we'll be left with x squared minus 16 over 9, right? Makes sense, right? It has to. Then from there, we're going to split. So we're going to make square root of 9 to have its own square root, and then this one to have its own square root, since these two things are multiplying each other. Makes sense, right? And then from there, we are then going to have 1 divided by square root of 9 is what? So we're going to have 9 multiplied by square root of 9 multiplied by square root of x squared minus 16 over 9. And then from here, you all can see that What is this? Square root of 9, we can take it out, right? So we can take out square root of 9, and that square root of 9 is what is 3, right? So it's going to be 1 over 3, and then on our numerator we have 1 there, and then dx, and then here we still have our x that we didn't touch, and then from there, what are we left with? We are left with making this. So already here we have x, okay, squared, minus, then we rewrite this nicely into squared. So this is going to be 4 over 3 squared. You understand? So this is going to be 4 over 3 squared, just like that. Okay, so now look at it. Now we have our f of x, which is the same as this f of x inside the thing, squared. Because I'm saying f of x because I'm referring to our formula. So I hope you are not confused with regards to the f of x's thing. So let me just show you the formula again before you get confused. Now I'm worried that you might be confused, and I don't want to confuse you. So let me just show you the formula again. So the formulas are these ones that I've attached here. So we're dealing with this kind of a guy, man. Yeah, we must make sure that we have f of x that is the same as here. So that means that whatever thing that we have here should be the same. If it's x squared, that means here should be x squared as well. So for the cases that for the question that we're dealing with, we have only x. So that x should be the same as the x that's here. You understand? There shouldn't be difference. And then on our numerator there, we should have the derivative of this. So if it's x here, then on our numerator we should have 1, because here on the numerator it is the derivative of what's here, you understand? And then there we have a squared. So that's just it. Is that then we can then conclude that that thing is equivalent to 1 over a second inverse of whatever thing that we're dealing with there, over a plus c. Makes sense, right? So yeah, let's quickly just go back to this question, and then I preach, and then I finish. So here we have x and x, like I've said. So x is our f of x for this case. So when we derivate x, we get 1, which we already have here. So meaning that this thing is already nice, right? It's written nice. Okay, so what's left? So the thing that's left, if we have the derivative of f of x there, and f of x and f of x are the same here, then we can then conclude that this thing is equivalent to 1 over a, right? Is equivalent to 1 over a. So this thing is then going to be, we're going to have this 1 over 3 multiplied by 1 over a. So our a here is 4 over 3. So this is going to be multiplied by 1 over a. So 1 over 3 that I wrote out here is this one. So this one, we take it to the answer, right? So now I'm applying the formula. The formula says that when you have this format, you just say your answer is equivalent to 1 over a. You understand? So the a here is 4 over 3. So that's going to be 4 over 3. You understand? So that's my a multiplied by the sec inverse of what? Our f of x. Our f of x for this case is x. So I'm just gonna write that x divided by a. So my a here is 4 over 3, then plus c. Then when you check here, 3 and 3, what do they do to each other? They chop each other. So at the end of the day, we'll just be left with 1 over 4. And then here, 1 over 4 over 3 is the same as 3 over 4. So meaning that the 3 here will go up. And then at the end of the day, this thing and this thing will end up being the same. So here we say the 3 and 3 cancel out, will end up giving 1 over 4 sec inverse of 3x over 4 plus c. Then that's it. So you can see that these two things are the same. However, I use different approach. You understand? So the third case here could be the following. So you can see that, okay, this one we're gonna get that. So as for the third case, so now let's discuss the third case. Okay, so let's just discuss the third case then. So the third case is going to be as follows. Remember, the question that we're dealing with says that we should integrate dx divided by x multiplied by what is this, 9x squared, 9x squared minus 16. So this is what we were dealing with. So now the third case is for someone that says that I'm mostly comfortable with working with a being equivalent to 1. You understand? So when you want your a to be equivalent to 1, then you then need to use this approach that I want to use. Makes sense, right? So so this is what, this is what, this is what. So this is how it's gonna be then. So that means we must take out 16 as a common factor there inside the square root. So this is how it's gonna go. So we're gonna have our 1, the x there, and then x, we have u here, and then inside the square root we are going to take out 16 as a common factor so that we end up having a. So this is going to be 9x squared over 16 minus 1, and then dx. So I took out 16 as a common factor. When you multiply this, you go back there because 16 and 16 will cancel out, and then we also have minus 16. So whatever I wrote here is the same as that. I didn't change the equation, okay? So we're still dealing with the same equation, so don't be scared there. Don't be scared. Okay, then from here we're going to split. We're going to make 16 to have its own square root and this thing to have its own square root. So at the end of the day, we're gonna have 1 divided by x multiplied by square root of 16 multiplied by the square root of 9x squared divided by 16, all okay, square root of 16 minus 1, and then we have our dx there. Makes sense, right? So square root of 16 is 4, right? So we can take out that 4 out. So this is going to be 1 over 4 integral of this thing 1, and then we have our x here, and then inside the square root, so inside the square root here, so here we have the x. Inside the square root we have, so 9x squared is the same as 3x squared, right? And then 16 is the same as 4x squared, right? So this is going to be squared minus 1 dx. So 9x squared divided by 16 is the same as 3x over 4 all to the power of 2, right? So I didn't change the equation again there. I'm still dealing with the same equation, you understand? So what we need to then make sure is that here we have, remember, the thing that's outside there should be the same as whatever that's squared there. So we need to make sure that here I have 3x over 4, right? So here I must make sure that I have 3x over 4. So this is, so I must write that 3x over 4. 3x over 4. And then as well as on my numerator, I should make sure that I have what? I have the derivative of this. So the derivative of this is just 3 over 4, right? So I should make sure that on my numerator, I have 3 over 4. So here, 3 over 4 and 3 over 4, they cancel out. So I don't have to put some things that cancel them out, because already they themselves they cancel out, you understand? They cancel out. It makes sense. That does it make sense? It makes sense, right? It has to make sense, right? I hope so. So from here, now we're dealing with a case whereby a is equivalent to 1, because 1 is the same as 1 squared. So I can just decide to write 1 squared here, right? So 1 squared is the same as 1, you understand? So now that we're dealing with a case whereby a is equivalent to 1, so these are the first formulas that I first show you. So let's quickly just go up there, and then I show you what I'm referring to in cases whereby a is equivalent to 1. So we're dealing with this guy here. So I don't know if I should just maybe okay, let me see what I can do. Maybe I can just paste him here for you so that we have that thing next to this question. So let me just paste this guy. So this is what we're dealing with, guys. So you see, this is the formula that we're dealing with. Remember, our integrals are this. So we have this right hand side. Now we're trying to go back here. Makes sense, right? So we have this format. Our a here, it's 1. So we have our f of x, which is the same as this. You understand? So we're trying to go back from here to there. So if when we check, we have 3x over 4, and the derivative of 3x over 4, it's 3 over 4. You understand? And then here we have 3x over 4, which is the same as this. Then that means we can conclude that whatever that we have here is the same as that. So that means the 1 over 4 that's outside will go with me to the answer there, and then I then conclude that the thing that's inside the integral is just equivalent to sec. So I'll then say that this is equivalent to sec inverse of our f of x is the thing that is squared. So the thing that is squared is 3x over 4. So I'll just write 3x over 4 and then plus c. Ta-da! I solved this question in 3 ways. Makes sense? So you will decide, guys, the method that you are mostly comfortable with. As for the questions that I'll be doing down there, I'll just decide to use one method, but you will need to remember that this could be solved in 3 ways. So whenever a is not equivalent to 1, we can always cook that thing to make sure that we end up getting the same thing. Makes sense, right? So yeah, let's just go back. Let's just continue. We're not going back, we are continuing. So now I need to let you know that these questions in your test exams, they won't just come directly in that format whereby you can see that now this has to be the inverse, you know. So sometimes you will then need to split the numerator terms and make each and every numerator term to have its own denominator so that you can make use of the inverse formulas and then integrate. So just like the question that I'm about to do here, we are given that the integral of x plus 2 divided by the square root of 4 minus x squared dx, we should integrate that. So to do this, we can see that there is nothing that we can do if we don't split this guy. So if we don't split, then there is nothing that we can do here. Like, we can't simplify, we can't do anything, we can't even force this to be the derivative of that, you know. It's not gonna be easy. So to solve this, we need to first split. Makes sense? So we need to first split. So let's split. So let's make each and every numerator term to have its own denominator. No more sharing. So this is going to be then equivalent to x divided by the square root of 4 minus x squared dx minus plus the integral of 2 divided by square root of 4 minus x squared dx. Makes sense, right? So let's check this one first before we check the other guy. So when we check, if I were to rewrite this nicely, then this is going to be 2 squared minus x squared. So let me rewrite this nicely. So this is the same as 2 squared minus x squared, right? So when we check, can x, if we let x to be f of x, can x be the derivative of x? No, right? That means that this thing is not what? It is not the integral of any inverse trig formulas, any inverse trig ratio, you understand? So this is not. That means we must think of something else, you understand? Makes sense, right? So if I just leave it like this, so what if I just let 2 squared minus x squared to be f of x instead? So if I let the whole thing like 2 squared minus x squared to be f of x, like the whole thing inside the radical sign to be f of x, then can this be f of x? Yes, because of when we derive 4, we're going to get 0 minus, when we derive minus x squared, what do we get? We get minus 2x. So I already have the x. The only problem that I don't have is that I don't have the coefficient of minus 2. So and I know that I can cook the coefficients whenever I want to cook them. So meaning that I can just put minus 2 there on my numerator and then cancel out the minus 2 outside the integral. Makes sense. And then since because of my n here for this case is not equivalent to minus 1, then I'll then be able to use the general power rule. So general power rule will forever haunt you. You must make sure that you are able to see them whenever they are presented there to you. So yeah, that's just it. So what am I gonna do here? The thing that I'm gonna do is as follows. So I'm going to rewrite this nicely again, understand? So let's rewrite this nicely by putting x here, and then my guy here, I'm gonna take him up, so it's going to be minus okay, x, let's put you here nicely. Hey, when I can't, what are you writing, bro? So it's going to be 4 minus x squared to the power negative half dx. So what did I do? I changed the radical sign into an exponential form and then took it up, and then it became negative. Makes sense, right? It has to make some sense. So we say that we are going to use general power rule, but we need to first make sure that the thing here is the derivative of this whole thing. So when we derive this, we get minus 2x, right? So we already have x, we're only left with minus 2, but then I didn't have minus 2. I then put minus 1 over 2 outside the bracket so that the minus 2 and minus 2 cancel out. Makes sense. And then from here, to integrate this, I'll just use general power rule. So let's analyze this guy and see what we can do to him. So when we check this guy, if we rewrite this nicely, it means that we're taking the 2 out. So let's take the 2 out. We'll be left with 1, and then we'll rewrite this 4 into 2 squared. So we'll have 2 squared minus x squared, just like this. So I just rewrote everything nicely. Makes sense. So when we check this guy, or maybe I shouldn't have okay. Okay, let me go back. I think I shouldn't have done this in this step. Okay, let's rewrite it in 4x squared. It's fine, but I'm still gonna do the same thing here. So let's rewrite this guy. Oh, it was 2 up there. It was 2, sorry. So it's going to be 2 integral. So what I'm gonna do, I just wanna rewrite this nicely here, because of if I analyze it, if I rewrite it nicely on this step, then that means the following step I must just integrate, you know. So I didn't want to integrate same time. So let me just lengthen these steps, and then they're gonna be like this. So this is going to be 2 squared minus x squared dx. Okay, so now I rewrote whatever that I had there nicely into this. You understand? The 2 is still there, still safe, and then 4 is still there, but it's written in this format. X is still there, x squared is still there, but written like this with brackets. You understand? So now I want us to analyze this in this form, in this following way. So if we let x to be f of x, can 1 be the derivative of x? Yes. So look at this format again. So when we have something like a squared minus this squared, which thing are we dealing with? Which case are we dealing with? What kind of a format is this when it comes to inverses? So you don't have to worry about. But if you cram, then yeah, it's a good thing that you have crammed, because you can't just always go back to your formulas every now and then. It will make your life tough. So it's this one of sine, you know, because we have for that question that we're dealing with, we've got 4 minus x squared, and we have 1 there. So we can just conclude that this is equivalent to sine inverse of what? Of x divided by 2, because of we have 2 squared there for the formula that for the question that we are dealing with there. Makes sense? it must make some sense. It should, yeah? So yeah, let's then conclude. We've already discussed my guy here. So my guy here is just gonna be 1/2. We use general power rule there. This is going to be 4 minus x squared to the power negative half plus 1. That's going to be positive half divided by what? Half. Makes sense, right? And then plus the 2 here, whatever that's outside the integral always should go with you to the answer there. Then you write the 2, you analyze this, you say that that's going to be sine inverse of what? Of f of x. Our f of x here for this case is x, so it's going to be x over a. Our a, it's 2, then 2, and then plus c. Then that's just it. You have successfully managed to integrate that thing. And then as for this case, definitely the 2 and 2 will chop each other. You will end up having, so maybe I can further rewrite this nicely and say this is going to be negative square root of 4 minus x squared plus 2 sine inverse of x over 2 plus c. Then ta-da, you have the same thing. So that's just it. So it's up to you basically where you want to end. But yeah, I advise you to always simplify to the last step. So yeah, that's just it. So I hope you understood, because we will do some activity questions there down there. For now, I was just trying to show you the kind of things that we are going to come across when we solve different questions down there. All right, let's also discuss this case, and then from there we're going directly into questions. So in when you're dealing, I repeat, when you are dealing with these questions, sometimes, or in most cases, they won't just give you that inverse directly, you know. They will want to confuse you. They will want to confuse you by giving you like a complicated quotient like the one that I have there. They will give you a complicated quotient. So sometimes you need to remember the things that we did in the previous videos so that you are able to survive on different questions that we'll be dealing with. So just like this case, look at it. We are given that the integral of sine inverse of x divided by square root of 1 minus x squared dx is what? So they want us to find out what is the integral of this. So when we check what definitely x, if we let x, yeah, so if we rewrite this nicely, meaning that it's going to be in this format, I'm going to put x here in my inside brackets. So I'm going to put x here inside brackets like I did there, you see. So when I put x inside brackets and I let that x to be f of x, so when I differentiate x, can it be sine inverse of x? Then I find that no way. There is no way. So what do you then do? Then you say no, it's not make sure. Then you try again, because you keep on trying, you know, you need to try. So then you say, what if I let just 1 minus x squared to be f of x? Can then this numerator be f prime of x? You say that this is not make sure, something is wrong here. Maybe this is a maths error. But then you don't give up, you know, because you're fighting there, you're fighting for your future there in the test. You keep on trying everything that you learned, you just try to apply it. You even try the x to be f of x. You say, what if dx is f of x? Then you say that now definitely I'm getting chopped. Then you stop whatever you're trying to do. Then you relax, you know, you breathe in, and then you say, okay, now I see, man, I can just rewrite this nicely, and then say, okay, to rewrite this nicely, I can put it in this format. So if I rewrite this nicely, then it's gonna look like this. So you remember that, nah, man, on YouTube there is this guy who likes rewriting things nicely. What if I just be like that guy, you know? I just rewrite this nicely, and then I'll have it in this format. You'll see that it will look nice, you know. You'll see that it will look nice. So I would end up having something like sine inverse of x. And then now you look at it, you say, nah, man, this looks good, this looks good, man. So after realizing that this looks good, then also ideas start coming up to your mind that, nah, bruh, look at it. This thing, if I let it to be my f of x, then this could be f prime of x, because I remember that whenever I'm differentiating the sine inverse of x, I should have the derivative of the argument on my numerator, and then I say square root of 1 minus this argument squared. So in this case, since the argument is x, then it's going to be x squared, and then that's it. So since I have f of x and f prime of x, and my n here is not equivalent to what, to -1, then I can just make use of general power rule, right? Then you say, nah, man, that guy, no wonder that guy is cooking YouTube there, bruh. That guy is good, bro. That guy is good. So I can just use general power rule. So all in all, guys, let's just use general power rule here, because if we let our sine inverse of x to be f of x, then this becomes f prime of x without us having to do anything to it. So let's just use general power. So general power rule, as long as you have f prime of x here, you don't stress. You just take this, you put +1 there on its numerator, on its exponent, on its exponent. You just say +1, and then you divide by n+1 again, then you say plus c, then that will be just it. So that's what we're going to do as well. So then here we're going to conclude that the answer for this is just sine inverse of x squared over 2, then plus c, then ta-da, you have your answer. So that's just it, guys. No need to stress. So that's what we'll be dealing with down there. So now we should check out some activities. So I hope you were grabbing the content there, because now it's time for us to solve different type of questions under this activity 6. So let's go. So I won't be showing you different types of methods, although more questions down here will or can be solved using three methods, like I've shown you up there, solving that one using 3 methods. So I won't do that for the sake of time. So but then you can do it to just to check if you can do it. If I did it, then maybe you can I believe you can do it as well. So yeah, you can just do it yourself there to see if, can I be like this guy. I think you can try. I think you can give it a try. You can give it a try, bro. You can give it a try. So yeah, let's then just integrate this. So now we've got the integral of 1 divided by 4 plus 9x squared dx. So before we start, I like rewriting this nicely first before I could do anything to it, before I could do any harm to it. I just want to I prefer rewriting it nicely before any harm comes to it. So that means I'm gonna write this a into in a squared form. So this 4 it's equivalent to 2 squared plus 3x squared. So I know that here on the numerator I should make sure that I have the derivative of 3x if I want to make sure that this thing is the integral of some inverse trig function. You understand? So if I let f of x to be if I let 3x to be my f of x, then I need to make sure that I have the derivative of 3x on my numerator there. So since I had 1 initially, I just need to make sure that I have 3x there. So the derivative of 3x then becomes what? 3, right? But then I didn't have this 3, so I don't want to change the equation into something else that looks that looks nice to be integrated. So I need to still work with whatever question that they gave me, right? So I need to cancel out that 3 by putting out 1 over 3. So 3 and 3 can cancel out. Then this goes back to the 1 that we had initially. But then I'm not going to cancel out because I want to make use of this. So in cases whereby we have f prime of x divided by a squared plus f of x squared, what do we then conclude if we are integrating that kind of a format? Then that's a tan, right? So that's just going to be a tan. So it's going to be 1 over a because of our a here is not equivalent to 1, right? So this is going to be just 1 over 3. Remember that the number that's always outside the integral, we always take it to our answer there, so it goes with the answer. So then this, because of our a here is not equivalent to 1, so we need to use that formula of 1 over a blah 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 blah. So for this case it's for tan, so it's going to be 1 over a. Our a is 2, so it's going to be 1 over 2, which is my 1 over a. That time is the tan inverse of what? F of x over a. So this is going to be 3x over 2, and then plus c. Ta-da! You have your answer. Of course, one can argue and say, "No, bro, why don't you simplify?" So this is going to be 1 over 6 tan inverse of 3x over 2 plus c. Then ta-da, you have your answer. So that's just it. So you don't need to stress about these things. As long as you can rewrite it firstly in a nice way, then you'll see that the thing that's going on here, it's a tan inverse. Then you conclude that it's that thing. But please conclude after you have made sure that on your numerator you have the derivative of whatever that you are squaring there. You understand? So yeah, that's just it. So yeah, time to watch a movie, it's over, guys. So if you were just relaxed there, not doing anything, just listening to me, looking at these questions like it's a movie, no, guys, you are doing the wrong thing. So please, from now on, from this question, please take out a piece of a paper there and a pen and a calculator, and then start doing these questions with me. What you need to do is just to pause the video before you check the memo, so you pause the video and then you try to do that problem or this problem, and then resume later to check the memo after you've done that question, so that you can see that are you also getting the concept. Otherwise, if you just watch this thing, listen to me, you'll sleep there. You'll sleep because I speak a lot, and maths is not that entertaining. It's maths after all. It's abusive. So please be working there by your side as well. Anyway, let's quickly do this question before I preach a lot. So we have another guy here. So the only missing thing is dx here. So what we need to do is to rewrite this firstly in a nice way before. So to do that, we need to rewrite this by saying, okay, the x there, it's there, and then we have the square root of a there. So let's rewrite this in a squared format. So this is going to be just 2 squared minus x squared squared. So x squared to the power 2 is the same as x to the power 4, right? And then I should not forget my dx. So what you need to do here is that you need to make sure that on your numerator you have the derivative of this for you to be able to use one of the inverses formulas, because you can already see that we do have that format whereby we have a squared minus x inside the square root there. On our denominator we have a squared minus f of x squared, right? So if here for this case we let x squared to be our f of x, then we need to force the numerator to be the derivative of this f of x. So f of x is x squared, so the derivative of x squared, what is it? It's 2x, right? So since we already have x, we can just cook the coefficient, right? The coefficient. So we can just cook the 2. So when we have cooked the 2, but then we didn't have the 2 initially, so you need to cancel out that 2 by putting out 1 over 2 outside the bracket, so that the 2 and 2 cancel out, and then you go back to the same question that you were dealing with. Otherwise, you will be solving a new question, which is not allowed. You should always solve the question that you're always given. Makes sense, right? So from here, if you have the derivative of f of x, then you can then conclude that this format of a squared minus a squared, and then on the numerator we have f prime of x, then you can then conclude that this is the format of sine inverse, right? So you take the 1 over 2 that's outside the integral to your answer, and then so the one of sine inverse does not have 1 over a, so you'll just say sine inverse of what? F of x is just x squared over what? Over a, your a being 2, and then plus c. Then ta-da, that's just it. You have your answer. So simple as that. Simple as that. Simple as what I did there. Alright, then now we have this guy. So we have the integral of 1 divided by 25 minus 16x squared dx. Remember that this question could be solved in a lot of ways. I've already shown you a way up there. So please, if you don't prefer the way that I'm doing, you could use one of the ways or one of the methods that I showed you up there. I showed you up until 3 methods whereby I use sometimes a being equivalent to 1, sometimes here we only have x, so those kind of things. So please, you will work with the one that you prefer. So for this case, I'll just prefer the one of a squared, the stuff like that. So what is it that we're dealing with here? We need to just make sure here we have okay, this is 1, and then we have dx. So what I'm trying to do here is to rewrite this in a nice way, so into whatever. So 25 is the same as 5 squared minus, so 16 is the same as 4 x squared. It's the same. 16 is the same as 4 squared. X squared is the same as x squared. So I can rewrite this as 4x squared like this, and then make 1 squared. So I can already say that this format is the one that I was dealing with on the previous question. It's the one of sine inverse. However, it's incomplete because of on the numerator I don't have the derivative of 4x. So I should make sure that on the numerator I have the derivative of 4x. So when I differentiate 4x, how much does it become? How much is it? It's just a 4, right? So here I need to make sure that I have a 4, but then because of I'm cooking this 4, I need to cancel it out. I don't need to change equation. So 4 and 4, they cancel out because of I would have put 1 over 4 outside the integral. And then from there, we can then conclude, since we have already discussed that this format of having square root of a squared minus f of x squared and then f prime of x there on our numerator, then we are dealing with a sine inverse, right? So this 1 over 4 that's outside the bracket always goes with you to the answer there. Then you conclude that this is the same as sine inverse of f of x over a. So f of x over a being 5 there, and then plus c. Ta-da! You have your answer there. So simple as that. These ones are very straightforward. Very straightforward. They are not tricky. If they are tricking you, we will have a problem. Okay, but I believe you are getting them, right? So what we need to do as well to this question is to rewrite it first in a nice way so that we can see our f of x is equivalent to this, and then make sure that that thing that we have is what. So when we check this, 9 is the same as 3 squared, and then plus 4 is the same as 2. Sec squared is the same as sec to the power of 2. So sec of x to the power of 2. And then here on our numerator we had sec of x tan of x, then dx. So if I so I can already say that this format is the one for tan inverse, right? Is the one for tan inverse. However, it's incomplete because of when I differentiate 2 sec x, I get 2 sec x tan x. So I only have I only have sec x tan x. I don't have a 2, so I need to cook the coefficient of 2, but I don't have to change the equation. I need to multiply by 1 over 2 so that the 2 and 2 they cancel out, and then make use of 2 sec x tan x divided by 3 squared plus 2 sec x squared, and then I conclude that okay, this one is the one for tan inverse, and my a here is equivalent to 3, so our answer here should be that one of 1 over a tan inverse of what. So 1 over 2, I'm gonna take 1 over 2. Remember, the thing that's outside the integral always goes with you to the answer, and then you put, since we've already discussed that this one is the one for tan inverse, right? So the one for tan inverse should have 1 over a, our a being 3, so this is going to be 1 over 3 multiplied by tan inverse of what? Of 2 sec of x divided by our a being equivalent to 3, and then plus c, which is the same as 1 over 6 tan inverse of what? Of 2 sec of x divided by 3 plus c. And tada, you have your answer. So I hope you got the same answer as the one that I got as well. And then from here, let's see if you can solve this one. So now we have the integral of 3 divided by the square root of 5 minus 9x squared dx. So what we need to do is to first also rewrite this in a nice way. So to do that, we then do this. So stay tuned. So we can take out the 3 out. We don't want to be disturbed by 3 there. So 3, we can just take you out. You are not 3. We don't want you to disturb us. We don't want you to disturb us. If ever, you will be a disturbance. So I don't think 3 here is going to be a disturbance though. although I took it out, I think I'll take it back in. So I realized after, hey, maths is somehow, guys. Why is it abusive like this? Okay, so 5, I can also write it in an a squared format by saying square root of 5. So square root of 5 squared. So square root of 5 squared is the same as 5, you know, and then minus 3x squared. So that 3, let me take you, I'm gonna take this 3 back inside because of I can say that it's of use, right? So let's take the 3 up. I took it back inside the integral because of I realized that when we derivate 3x, we just get the 3 that we were already given, you know. So when we analyze this format that I've written there, you will see that we have square root of a squared minus f of x squared, which is that one of sine, right? So whenever we have this one of sine, whenever we have this format, then we can conclude that the thing that was differentiated for us to get this quotient was sine inverse, because of we have the derivative of f of x. If we let 3x to be f of x, then 3 is going to be the derivative of 3x, right? So we can then conclude here. So the one of sine inverse does not have 1 over a, guys, outside the thing. So it's just gonna be sine inverse of what? 3x over a inside. So our a here is square root of 5, then plus c. And tada, you have your answer there. So that's just it. That's just it. I hope you got it as well. Yeah, I hope you're pausing the video there. We don't want you to get chopped in the test. So if you're pausing the video, then you stand a very good chance of chopping these things in the exams, the test, the semester test, whatever that you'll be dealing with there. Whether it's a semester test, tutorial test, class test, as long as the test, you'll chop that thing. Okay, so now we're dealing with the integral of 1 divided by x plus x squared ln of x ln squared ln of x everything squared. Okay, so this is going to be, so what you need to do here, you can already see that this is the one for a tan, but then it's not written in a nice way, right? It's not written in a nice way. So what we need to do is to rewrite this in a nice way so that we don't have to get confused. So this x, we can take it up by rewriting 1 over x there, up there. And then here on my numerator, I'll just be left with this squared dx. So when we have, okay, we can see this format is the one for a tan because 1 is the same as 1 squared. So what do we do here? So since we have 1 plus this squared, and then we can see that if we let ln of x to be f of x, then 1 over x can be is the derivative of ln of x, right? So 1 over x is the derivative of ln of x. So what do we then do? We then conclude that the thing that was differentiated for us to get this quotient was that one of a tan, right? So from here, we will then say, okay, since we have 1 here, then is the first, those we're dealing with the first formula, so we're not going to have 1 over a here, which will just say tan inverse of f of x. So our f of x is just a ln. So therefore, the answer here will just be tan inverse of ln of x, and then plus c. Ta-da! You have your answer. So these ones are straightforward, right? They are very straightforward. Make sense? It has to make sense. Okay, now we've got ourselves the integral of 1 divided by 2 plus 7x squared. What do we then do? We need to start by first rewriting this in a nice way before we can make any conclusion. So to rewrite this in a nice way, we can already see that it's the one for a tan, but we need to make sure that we can see our a there, that it's what. So also we should again make sure that we have the derivative. Okay, so okay, here we have 1 on our numerator, we have a 1, and then we have dx, and then inside the square root we've got 2, or we've got square root of 2 squared. So 2 is the same as square root of 2 squared, you understand? So this will go back there, and then plus so 7 is the same as square root of 7 squared multiplied by x squared. Okay, since we can see that when we have oh, what did I put a square root now? I don't know, guys, I'm very sorry. I don't know why I've put the square root there. That means I must like or love the square root. So I'm very sorry for putting the square root there. Don't know, what was I doing there? Maths. Okay, so we can already say that this format is the one for a tan, right? So this one is the format for a tan. So what we need to make sure is that we have the derivative. So we need to make sure that when we let our f of x to be 7, square root of 7 multiplied by x, then we should have the derivative of that there on our numerator. So we can see that the derivative of this thing inside the bracket is just square root of 7, right? So when we check on our numerator, we just have 1, so we should make sure we have square root of 7 there before we could apply the formula for tan. Yeah, square root of 7 there. Yeah, there it is. And then so this is going to be so because of we didn't have this square root of 7, what should we then do? We need to cancel it out by putting 1 over square root of 7. Yeah, makes sense. And then when we have this format, and we can say that it's the 1 of a squared plus f of x squared on our numerator having f prime of x, because of square root of 7 is just the derivative of this, right? So we can then conclude that this whole thing is for the integral of this quotient is just the one for tan inverse, right? So this is going to be, so the 1 over square root of 7 is going to go with you to the answer. And then since it's the one for tan inverse, we will know that outside that tan inverse there should be 1 over a, and our a here is 1 over square root of 2. So 1 over our a here is square root of 2, I mean. So we should make sure that outside the thing we have 1 over a multiplied by the tan inverse of what? The tan inverse of our f of x. So our f of x being what? Being square root of 7 multiplied by x upon a being equivalent to square root of 2. Square root of 2. Makes sense? So this is going to be that thing divided by that, and then plus c. And then what is this? So 1 over square root of 7 multiplied by this 1 over square root of 2. This is going to be the 1 multiplied by square root of 14. So when you have two roots, when we have two square roots multiplying each other, you just multiply the thing inside and then you put 1 square root. So it's going to be 1 over square root of 14 tan inverse of square root of 7 multiplied by x over square root of 2, then plus c. Ta-da! You have your answer there. Maybe someone else could just say, I want to also just say square root of 7 divided by square root of 2 is the same as maybe 14 over 2 or or 2 over 14, depending on what you want to write. So yeah, you can stop here, or you could just use the calculator and say square root of 7 divided by square root of 2. It will give you like something like square root of square root of what? Square root of 14 over 2. So yeah, maybe you can go further from here. So yeah, but that's just it. That's just it for that question. I hope you got it as well. It was an easy one. So let's see if you can solve this following one. This following one, it's easy as well. So when we check this one that I just attached there, we can see that we need to first rewrite this in a nice way first before we can make any conclusion, because of it's not direct that this was differentiated to get this, you know. But if we could first rewrite it nicely, then we can make some conclusion there. So let's take the 5 out. So 5, I've taken you out, my bro. 5, I've taken you out. And then here I'll be left with 1 divided by the square root of 1 minus x over 2, and then squared multiplied by. So these are those cases whereby you can see that maybe a general log rule, general power rule was used over. So these are those cases. I've explained this thing there before we started the activities. I've explained some examples there. So it's those types. So you need to also be able to say that it's them, right? So multiplied by sine inverse of x over 2, and then to the power negative of. So what did I do here? I changed this square root into an exponential form to become 1 over 2, and then I took it, since it was in the denominator, I took it up, and then it had a negative exponent there from there, and then we actually forgot my dx there. So from here I can see that if I if I differentiate sine in, if I let sine inverse of x over 2 to be my f of x, then I can have this to be my f prime of x. Makes sense, right? Because when I differentiate sine inverse of x over 2, I should have 1 over 2 on my numerator, because I need to differentiate the argument on the numerator and then say divided by the square root of 1 minus this squared. So this squared, it's already there. The only missing thing is the derivative of the argument on the numerator. So meaning that I should make sure that here where there is 1, I should have 1 over 2. Make sense? And then because of this 1 over 2, I'm cooking it, I should make sure that I have the 2 that cancels it outside there. So here I should multiply by 2. Make sense? So that these 2 can cancel out this 1 over 2. Makes sense, right? And then if I have this as my f of x and this as my f prime of x, then also my n here is not equivalent to -1. Then I can make use of general power rule. General power rule. So to do that, so whatever thing that's always outside the integral must go with you to the answer. So here this is going to be 10 multiplied by sine inverse. So this is going to be, you just take your f of x there and that the n that it has, and then you say you add 1 on that n. So 1 over 2 minus 1 over 2 plus 1 will give you a positive half, and then divided by positive half plus c. And then from there, you can see that the 2 here will go up, or 10 divided by 0.5 is the same as 20, right? Is the same as 20 multiplied by, so exponent of that is the same as a square root. So we can then say this is the same as sine inverse of x over 2 plus c. Ta-da! You have your answer. So simple as that. Simple as that. You don't have to worry about it. You don't have to worry or stress about it. And then from here, we can again solve this question that I attached here. So remember to pause the video so that you work out this problem on your own and then resume later to check the memo, of course. So what we can do here is to first rewrite this in a nice way, because already we can say that it could be that 1 of 10, but it's not written in a nice way. So before you can make conclusions, you need to first rewrite this thing in a nice way. So you are going to get x squared to the power of 2 plus 9 dx. Okay, dx. So already on my numerator I had x, so I can say that this one is that 1 of a 10, right? Okay, let's change also the 3 to have the 9 to be 3 squared. So I can say that this is the format of tan inverse. So what I need to do before I conclude that, I just need to make sure that on my numerator I have the derivative of x squared, you know. So the derivative of x squared is 2x, right? So I have x, so I can just cook the coefficient of 2 and then cancel out the 2 by multiplying by 1 over 2 outside the bracket, outside the integral. So if I have f prime of x and f of x here, and this is, I can see that this is the format of tan inverse, then I can conclude that the thing that was differentiated to get this integrand was, okay, this 1 over 2 should go with me to the answer. And then because of I say this is the one for tan inverse, it should have 1 over a, because our a here is not equivalent to 1. So 1 over a here is going to be 1 over what? 1 over 3. So that's our 1 over a multiplied by the tan inverse, right? So this is going to be the tan inverse of f of x is just x squared over a. Our a is 3, then plus c, and that's just it. And then one could just say I want to take it further to 1 over 6, and then tan inverse of x squared over 3 plus c, and ta-da, you have your answer there. So that's just it. That's just it. That's just it. So Yeah, I hope you got that one as well, because now you are pausing the video to work out these problems on your own, right? So I hope you got it. So now we have the integral of Vx divided by square root of 3 minus 2x squared. So we need to first rewrite this nicely before we can make any conclusions. Of course, we can say that this one is going to be the one of a sine, but then before we do that, we need to first rewrite it nicely. So to rewrite it nicely, we need to do this. So the square root. So we need to write this 3 in our a squared format. So this is going to be the square root of 3 squared minus square root of 2 times x squared, and then dx, and then there on our numerator we had 1. So whatever that I wrote here is the same as the thing that we have there, right? So I can already say that this format of a squared inside the square root having a squared minus f of x squared is that one of sine, right? Sine inverse. So what I need to make sure before I conclude is that I need to make sure I have the derivative of this on my numerator. So the derivative of this is just going to be root 2, right? So I need to make sure that here I have root 2. But then I didn't have root 2, so I should multiply by root 2 outside the bracket. So root 2 and root 2 will cancel out, and then at the end of the day, now you will then be able to conclude that this is the sine inverse. So the thing that outside the integral, you should always just take it with you to your answer there. And then the one of sine inverse does not have 1 over a outside, so we just say sine inverse. The 1 over a is inside the argument there. So then you conclude that this is going to be square root of 2 multiplied by x divided by a, which is what? Root 3, and then plus c. Ta-da! You have your answer there. So that's just it. That's just it. Okay. Let's see if we can solve something else. All right. So we have this format now. This is also easy, provided that you first rewrite these things in a nice way first before you can just make some conclusions. So we can already see that we have a tan inverse because of x squared plus 1, you know. So yeah, what we need to do is to rewrite this thing firstly before we make some conclusions. So this is going to be 1 over x squared plus 1 multiplied by e to the power tan inverse of x, and then we have what? Our dx. So this is how it's going to be, right? So we can say that now, man, since we have this exponential function, then it means that this exponential function was differentiated for us to get this whole thing, right? Because of, we know that whenever we're differentiating an exponential function, so whenever, let me just write this here, maybe here on the side here, just to remind you of some things. So the du of e to the power u is what? Is equivalent to e to the power u multiplied by u prime, you know. So remember, in integration we're given the answer, so that means in integration we're given this. So this is u here, what I'm writing, it's a u. So in integration we're given this, we go back there. So meaning that in integration you'll have an integral, and then you are supposed to go back there. So whenever you have this format, you can just conclude that this is this. So meaning that in integration, if you have an exponential function with with the derivative of that exponent, you know, then you can then conclude that the answer for that integral is just the thing that you have there. It's just that exponential function, you know. So that's what it means. So that's what I'm trying to say to you. So let's just erase this, because I was just trying to remind you. So we can see that we have this exponential function, and the derivative of this exponent of tan inverse is the same as 1 divided by x squared plus 1. So we can just conclude that the answer for this whole integral is what? It's e to the power tan inverse of x, and then plus c. Ta-da! You have your answer. So that's just it. So I hope you are getting these things as well. I hope you are getting them. They are very easy peasy. Okay, now we have this integral of 1 divided by x into multiplied by the square root of 3x squared minus 2. So what we need to do is to rewrite this in a nice way first before we can conclude. Okay, so this could be solved in a lot of ways, right? So I'm not gonna use all the 3 ways. I'm just gonna solve it using one way. Makes sense, right? So this is how it's gonna be. So let's rewrite this in a nice way first. So this is going to be, okay, we have x here. When x, we can just leave you there, and then here inside the thing we can just say, okay, we're going to force this whole thing to be f of x somewhere somehow. So let's rewrite 3 in the form of what squared thing. So 3 is the same as square root of 3 squared. So let me write square root of 3 and then x squared. So what I wrote here is the same as 3x squared, right? You can see it because of, you can see, yeah, I don't have to preach a lot when it comes to that. So let's write 2 as well in the form of what squared. So this is going to be square root of 2 squared, like that. So from this thing of that, we are then also going to say, okay, we have 1 here on the thing. So before I do anything, I was just wanting to say that whatever that I wrote here is the same as the thing that I have up there. So we can say that now, man, this format is that one of sec, right? Is that one of a sec. So what we need to make sure is that since here we have this format of a sec, then we need to make sure that this is f of x, and on our numerator we should have the derivative of this, and then here we should have exactly whatever that we have here, because this should be f of x and this should be f of x. So if I have square root of 3 here, then that means also here I must have square root of 3, and then here again I should have square root of 3, and then square root of 3 and square root of 3, they cancel out to give me back the 1 that I had initially here, you understand? But then if I just leave them like this, I can then conclude that this format is that one of sec. So I can then conclude that the thing that was differentiated for me to get this quotient was that one of a sec, and that one of a sec is 1 over a. So it has to have 1 over a. So my a here, it's root 2, 1 over root 2 multiplied by the sec inverse of what? So here I'm going to have sec inverse of, so my f of x here is going to be root 3 multiplied by x divided by a. So a is root 2. You understand? So this is going to be root 2 and then plus c. And then that's just it. And then from there, what is this? From here, maybe one could say, we know that 1 over root 2 is the same as root 2 over 2. So you can write it in whatever way that you want to. So 1 over square root of 2 is the same as root 2 over 2. You can also just punch it there on your calculator. You'll see those two guys are the same. So yeah, you can leave it here for this one. So I hope you got it as well. It was easy. It was easy indeed. It was easy, It was easy. So what do we have here? We have the integral of 1 dx divided by 1 plus x multiplied by that guy up there. Okay, we have this thing. So when we analyze it, this could be solved in what ways? In maybe 2 ways, 3 ways, I don't know. What do you think? What do you think, guys? So since we have 1 plus x, maybe one could say I can just multiply out by that square root, and then I will end up having 1 plus x to the power, what is this, x, oh, I mean, I'll end up having x plus x to the power 3 over 2. Can that help us? Because at the end of the day, we would have multiplied, but then I don't think it's gonna be of use because of we'll get stuck. Because imagine what we're gonna have here. So let me just write the thing that we're gonna have here. If you ever think of, let me just multiply out. So you will end up having just x, or square root of x, I mean square root of x, or x to the power half, plus x to the power 3 over 2 dx. So you will end up having something like this. So when you have something like that, what will you then do? So you see, you will get stuck, right? So what if you just do this? You just let you just yeah, this thing maths, right? So what if you just let this thing of, what if you just rewrite it in this format? So this thing is tricky because of you had to rewrite rewrite this in a nice format first. So when you rewrite this in a nice format, you're gonna have this. So let's you'll see the importance of rewriting this in a nice format, guys. But this one was tricky, I understand. Yeah, this one was chopping. I believe I believe that people could get chopped by how this is. So this is the same as x to the power of half squared, and then I'm going to take the root up. So when you take the root up, what do you have? You're going to get x to the power negative half dx. Makes sense? So what I did here, I rewrote what we were given nicely. You understand? You should understand. You should understand. So let's look at it. So I just took the root up, and then it changed the exponent. Of course, it should be negative half. And then this one, so I wrote x to the power 1. Here we had x to the power 1, right? I wrote 1 like in a square root form. So instead of, so here what I did initially is just to write x is the same as square root of x squared, which is the same as x to the power half squared. So that's basically what I did here. So that's basically what I did. So with the thing that I did here is basically what I did here. You understand? I hope that makes sense. So I can see that if okay, I can see that this is the format of a tan inverse, right? So I need to check, if I let this to be f of x, can this be f prime of x? Yes, because of when I differentiate x to the power half, what do I get? I get so dx of x to the power positive half is going to be x to the power negative half multiplied by half. So it's going to be half to the power negative half. So what's missing? So already here I can see that I already have the x to the power negative half. I don't have the half outside, so I don't have the half. So I can just put the half and then cancel it out by putting a 2 outside the thing there. So I can see that this is the one for tan inverse, right? So I don't have to stress myself. I can conclude because of if I let x to the power half, so if I let x to the power half to be my f of x, then this is going to be my f prime of x. And if I have f prime of x divided by 1 plus f of x squared, then I can conclude that this was tan inverse that was differentiated for us to get this quotient. So the 2 that's outside the integral, I'll take it with me to the answer and then say this is just tan inverse of x to the power half, and then plus c, x to the power half is just the square root of x, so you can just write it in that format or using the square root of x format. And then here we're not gonna say 1 over a because our a is equivalent to 1, so even if you can say 1 over a, so it will still be 1 over 1, so it's the same thing. So yeah, then that's just it, and then you got your 2 marks, or your marks if it's 2 marks, 3 marks, I don't know, whatever marks that they're gonna give you in the exam. So whatever mark that they give you, you should be able to get them like that. And then let's see the other thing that we can solve here. Okay, now we've got the integral of x divided by this. We can already say that this one is simple, right? But before we take chances on it, or before we conclude, we need to first rewrite it nicely by first doing this. So this is going to be 2 squared minus x squared dx. So I had the x there, so I can see that already this format is the one for sine, right? Is the one for sine inverse. However, it's incomplete because of on the numerator I should make sure that I have the derivative of f of x, so meaning that I should make sure that there is the derivative of x squared. When I differentiate x squared, what do I get? I get 2x, so I should make sure that here I have 2x, and then I cancel out the 2 by putting 1 over 2 outside the bracket, and then this is going to be so then from there I can conclude that the answer for this is just going to be 1 over 2. The 1 over sine inverse does not have 1 over a outside there, so this is going to be sine inverse of f of x being x squared over the a here being 2. So this is going to be just 2, then plus c. Ta-da! You have your answer there. So simple as that. Simple as that. So simple as that, right? So from there, you're also going to do this one. So to do this one, you need to first do what? You need to first just do this. So you need to first rewrite it nicely before you can make some conclusions. So you can say that this one is already in that format of what? Of sine as well, because of we have a squared minus whatever thing f of x squared there. So to rewrite this nicely, you need to do this. So I can say that the thing that was differentiated or somewhere somehow, I should take the 1 over x up there, because I can see that if I want to force this to be f of x, then the derivative of this must have 1 over x. So this x is misplaced. So I'm going to take it up, and then it will end up becoming a 1 over x when I take it up. And then here, I will have 3 squared minus 2 ln of x squared. So I successfully managed to rewrite this nicely. So 9 is the same as 3 squared, and then 4 ln squared of x is the same as 2 ln of x. You understand? Because I will be squaring them here. So this is going to be 4 ln squared of x. So I can see that already this format is the one for sine inverse, right? However, I can't just say this is the sine inverse of this without making sure that on the numerator there I have the derivative of this, right? So I need to make sure that on the numerator I have the derivative of 2 ln of x. So the derivative of 2 ln x is the same as 2 over x. So I need to make sure that here I have a 2. But since I didn't have the 2, I just cooked it. I need to cancel out the 2 by multiplying by 1 over 2. Then now, since I have the derivative of this, and this is in the format of sine inverse, then I can then conclude that I can take the 1 over 2 to my answer and say this is equivalent to the sine inverse of what? Of 2 ln of x divided by what? Divided by a, which is 3, and then plus c, and then that's just it. And then one might decide to flex and say sine inverse here is the same as okay, you can just decide to flex and say 2 over 3. Okay, you can take this 2 over 3 to become the exponent of this, meaning that you would have applied the properties of exponent, the laws of exponent. Basically, is it the properties or the laws, whatever law, whatever thing, that property or laws, you would have applied. At the end of the day, one of you could argue and say this is the same as sine inverse of ln of x to the power 2 over 3 2 over 3 to to the power 2 over 3, then plus c. Ta-da! That should be your answer. So yeah, that's how you would have done it if you solving this. So it's what did I do there? I did this. So when you have ln to the power a of n, then this is the same as n ln of a. So that's what I just applied here, you understand? So we had 2 over 3, which is just the same as that thing being taken up there. I hope it makes sense. So yeah, that's just it. That's basically what I was trying to do there. So yeah, let's quickly just do this following one. It's also simple, right? You can say that already that we are dealing with tan inverse, because of we have a plus whatever thing plus something squared, so it's tan inverse. However, we can't make the conclusion without rewriting it first in a nice format. So here we're going to get cos of x divided by square root of 5 squared plus sine of x squared dx. So when we have this, then we can conclude that what can we conclude? We can conclude that this is tan inverse, because of when we let sine of x to be f of x, then this is going to be the derivative of that. So we don't have to stress about this. This is just going to be 1 over a, because of our a here is not equals to 1. So our answer should have 1 over a, which is going to be just 1 over 5. 1 over square root of 5, and then tan inverse of what? Of f of x, which is sine x for this case, divided by a, which is square root of 5, and then plus c. Ta-da! You have the answer. So that's just it. That's just it. Makes sense, right? Makes sense. So yeah, that's basically what you are supposed to do. All right, so let's see if we can solve this following question. Okay, so I hope you're also getting these questions, because of they are easy and you should be able to get them. So when we see this one already is the one for sine inverse, right? Is the one for sine inverse, but then we cannot conclude because of we didn't first write it nicely. So we need to first rewrite this nicely to see what is what, to see what is our f of x, what is our a, those type of things, so that we can avoid mistakes. So let's rewrite this first in a nice way. This is just going to be the square root of 1 minus 16 is the same as 4. Tan squared is the same as tan of 2x for this case, and then we are going to square you guys so that you can go back to how you were before. We are not here to change the equation. So okay, up there we had sec squared. We had sec squared of 2x. So we can see that already this format of having 1 minus f of x squared is the one for sine inverse, right? So what we need to do is just to make sure that on our numerator we have the derivative of 4 tan 2x. So when we derive 4 tan 2x, we get what? We get 4 multiplied by sec squared of 2x multiplied by 2. So at the end of the day, we should have 8 sec squared. So we don't have an 8 there. So we should make sure that here we have 8, and then we cancel out the 8 by putting 1 over 8 there, and then from there we conclude then that this is so the 1 over 8 will go with you to the answer, and then this is going to be sine inverse of what? Of 4 tan of 2x, tan of 2x divided by a, which is 1. So I don't have to write to that 1. Of course I should have just said 4 tan of 2x. So now I'm used to these ones of a being equivalent to something else, but it's the same thing. So because of our a here is 1, I don't have to say 4 tan 2x divided by 1, right? So I can just write it like that, simple like that. So that's just it. I hope you got it. It was an easy one. Okay, let's see if we can solve another one. Okay, now we have ourselves this one. So when we check this one, what's going to happen? Yeah, okay, we need to first rewrite it nicely first before we can make some conclusion. Of course, we can say it's the one for tan inverse, but then without rewriting it first in a nice way, we are going to get chopped. So I don't want us to get chopped, so please let's not get chopped. So this is going to be equivalent to tan of x multiplied by sec squared. So sec squared of x. And then down here we're going to write that 3 in this format of what squared plus tan. We're also going to write you nicely, so you are going to become tan of x squared to the power of 2, and then dx. So we can see that because of we have something like a squared plus f of x squared, then we have tan inverse, right? So before we conclude, we need to first make sure that the thing that is inside the numerator is the derivative of this. When we check the derivative of tan x squared, what is it? Is going to be equivalent to 2 tan x multiplied by the derivative of tan, which is going to be sec squared. So already have tan x sec squared. The only missing thing is us having the 2 here. So we need to cook the 2 outside there. So this is going to be 2. We need to cook the 2 here so that this becomes fully the derivative of this, right? But then we didn't have that 2. The 2 was just cooked. So let's cancel the 2's by putting out 1 over 2 there. And then from here we can conclude, because of we have the derivative of tan to the power 2 on our numerator, then we can then say this was this is the derivative of what? Of tan inverse. So the answer for this integral is just 1 over a, our a being root 3. So let's take this 1 over 2 to our answer. 1 over 2, then 1 over a is going to be 1 over root 3 multiplied by tan inverse, right? So this is going to be tan inverse of what? Of tan squared of x divided by a being root 3, my a being root 3, and then plus c. Ta-da! I have the answer there. I have my answer there. So that's just it. I hope you understand the thing. So I hope you're also not tricked by the chain rule that we use to differentiate this. So you're first going to say 2, you put the 2 down there, you differentiate, and then you subtract 1. Then after that, you say multiplied by the derivative of this. That's why you end up getting something like this. So yeah, it's chain rule that we use to differentiate that. So yeah, and then yeah, your answer is going to be equivalent to this. Make sense? It should make some sense. Okay, now we have this guy. So we have this guy here. It's e to the power x. Okay, it's e to the power x divided by what? It's e to the power x plus e to the power 2x divided what am I saying? So now we've got the integral of e to the power x plus e to the power 2x divided by e to the power 2x plus 1 multiplied by dx. Makes sense, right? So from here, what are we gonna do? We are going to split, because of, we can see that already here this one is that format of requiring us, is that format that requires us to split. Makes sense, right? Is that format that requires us to split. Okay. This one is interesting as well, because it wants us to remember that thing of the exponential functions, the integral of exponential function. I think it's activity 4. So there is something that we need to cook there from that activity. So what we need to do first is to first split before we could think of anything. So let's split. So to split this, we'll end up having e to the power x divided by e to the power 2x plus 1 dx plus the integral of e to the power 2x divided by e to the power 2x plus 1 dx. Okay, so here we can see that this one, it's what? So this one is the format. This format could be that one of tan. However, we need to rewrite this first in a nice way, right? So to rewrite this in a nice way, this is how it's going to be. So we're going to have e to the power x divided by e to the power x e to the power x squared plus 1 dx plus the integral of what? Of what we have here. So this is just going to be e to the power 2x divided by e to the power 2x plus 1 dx. Okay, the x like this. So what are we supposed to do here? So here we are supposed to okay, this one, okay, let's start with this one before we can discuss that one. We can see that this one is going to be what is going to be the one for tan, because of what? Because of, we can see that we have f of x squared plus 1, and then also if we let e to the power x to be our f of x, then the numerator here is going to be the derivative of e to the power x. So here we can conclude that this one is just the one for tan inverse, and also because of our a here is equivalent to 1, so we can just use those first formulas there. So this one won't have, what I'm trying to say is that it won't have 1 over a because of our a is 1. Makes sense, right? And then as for the second integral there, so if we so this one can be that one of what? Of tan inverse, because of what? We cannot say when we differentiate, we cannot square this and make it like this, and then we say when we differentiate e to the power x, it becomes e to the power of 2x. You understand? So we can't do that. What we can do here is just to use another rule. Okay, since the e to the power x thing is failing, so it's failing to be the inverse, this one, so we're going to try making the whole thing here on the denominator to be f of x, meaning that we're going to say this thing to the power 1. You understand? So when we make this whole thing to be f of x, then we're going to have e to the power 2x plus 1 as our f of x. So if we let it to be our f of x, then we are going to have the derivative of it to be e to the power 2x multiplied by 2. And when we check, our numerator can be the derivative of this, right? Our numerator here can be the derivative of this whole thing. However, it's incomplete. There is a missing 2, since when we derive it, there should be 2. It should be 2e to the power 2x. So I'm going to put that 2 that's missing and then cancel it out by putting 1 over 2. So here I've already discussed that this one is going to be the one for tan inverse. So this one is just going to be tan inverse of what? Of e to the power x. We come to this. So because of here, we have the derivative of the denominator on our numerator. It's what? It's general log rule, also because of our n is equivalent to 1. So yeah, and then so that's going to be 1 over 2 ln of what? Ln of 2 to the sorry, so this is going to be e to the power 2x plus 1, and then you close, you say plus c, then boom, ta-da, you have your answer. Easy, 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 easy busy. All right, so I hope you got that one. It was an easy one. It was an easy one, of course. So let's see what we can do to this following question. So now we've got ourselves the integral of x plus 1 divided by 9x squared plus 4 dx. So we can already say that we need to split first before we can do anything to this question. So let's split, because it's in that format of splitting, right? So we need to first split. So let's then split. So to split this, we are going to get x, or just x, divided by 9x squared plus 4. Okay, and then dx plus the integral of 1 divided by 9x squared plus 4. And then from there, I should have my dx here. So when we check this one, we are going to have inverses, 2 inverses here in the end for this question. So it could be 2. Can it be 2 inverses, or I'm just taking chances? So it can't be 2 inverses because of, so yeah, this one can be an inverse because of, if we force this, so if we rewrite this nicely, like we say this is equivalent to 3x squared, then we can see that when we differentiate 3x, we can't still have x, you know. So it's failing to be an inverse, this one. So for us to differentiate it, we need to try another. To integrate it, we need to try another method, right? So this is going to be, let me write it as 9x squared still. So however, if we let this whole denominator to be equivalent to f of x, then what are we going to do? we are going to differentiate it and see what's and see if the denominator can be the derivative of this. So when we differentiate that denominator of 9x squared plus 4, we are going to get 18x, yeah, just 18x. So we need to then cook. So we need to cook this numerator to be 18x. So we're going to put 18 here and then put 1 over 18 outside. And then as for this case, we need to rewrite it nicely, because this one we can force it to be the inverse one. So 9x squared is the same as 3x squared, and then the 4 is the same as 2 squared. And then as for, since we have 1 here, and we need to make sure that on the numerator we have the derivative of this. So the derivative of 3x is just 3, so we can put 3 and then have 1 over 3 outside there. So 3 and 3 are going to cancel out. So 3 and 3 are going to cancel out there. And then when they cancel out, this goes back to the one that we had initially. So meaning that I didn't change the equation. So we can just apply the thing now. So now we can integrate. So when we have the derivative of the denominator on our numerator, and then our n here is equivalent to 1 on the denominator, then we can conclude that this is the natural log that was differentiated for us to get that thing, plus 4. And then plus, we take the 1 over 3 for this other side to our answer. We multiply it with so this is going to be the integral of this is going to be that one of tan inverse, because of we have f of x squared plus a squared, right? And now that our a is equivalent to 2, then we are going to say 1 over a here outside. So 1 over a, which is 1 over 2 multiplied by tan inverse of what? Tan inverse of 3x over 2. And then plus c. Ta-da! We have our answer. And then one of you can say, I want to take this to be 1 over 6. It's correct. It's correct. It's correct. Woo. Yeah, math is tiring. It's tiring, but yeah, let's keep going. Yeah, I hope it's worth it for me as well as for you. Maybe it can, maybe this is also worth it for me, like to be doing this. Maybe it's also worth it. I hope so. Basically, I hope so, because for you definitely it's worth it. You're going to write a test, so you need to understand these problems. You need to understand these problems, and you need to practice. As for me, we don't know. But yeah, let's keep on going. So now we've got the integral of this 2x to the power 4 minus x squared minus x squared divided by 2x squared plus 1 dx. So we've already okay, maybe I should give you a chance to analyze this. Okay, let me just give you a chance. So when you check, okay, now that you have analyzed, let me just explain, just to avoid wasting time. So you can see here, if we can split this thing, then the chances are we'll still have a problem, because we'll still have 2x to the power 4 divided by 2x squared plus 1, which still looks like a problem because of what? Because of, we can see that we can't force 2x to the power 4 to become the derivative of the thing that's in the denominator somehow. So we're still gonna have a problem. But then as for this one of x squared, maybe we can cook something from it, you understand? So what are we gonna do then? So we need to remember everything from activity 1 of integration, then, that whenever, another one, well, before I say that, one person could have said, okay, if I take x squared here as a common factor, I will have x squared into 2x squared minus 1, which is still a problem because of nothing cancels out, so you still have a problem. So what can we then do? So you then remember that now, bruh, whenever the degree of the numerator is greater than the degree of the denominator, we can just make use of long division method, and then we rewrite the given quotient in a simple way. So that's what we're gonna do here, because the other ways are failing. So let's then see. Then we analyze this. Okay, this is going to be this multiplied by this. Okay, I'll take you up a bit. Okay, so this is going to be this way. My divisor here, it's 2x squared plus 1. My dividend, it's 2x to the power 4 minus x squared. So when I analyze this, I realize that, okay, I have 2x to the power 4, so I need to divide. So I'm going to say 2x to the power 4 divided by 2x squared. I'll get what? I'll just get x squared, right? So I'll just get x squared here. So it's going to be x squared, which will multiply everything. So it's going to be x squared multiplied by this is going to be 2x to the power of 4. Again, it multiplies 1, so I will end up having plus x squared, and then I introduce the negative sign. I then add the dividend with this term, so it's going to be 2x to the power 4 minus 2x to the power 4 is going to be a 0, and then minus 2x squared minus x squared divided, and minus x squared minus another x squared will get minus 2x squared, right? And then here we can we divide again? Yes, we can divide again, because of these degrees are equal. We can only stop dividing whenever this degree is less than that degree there. So we can divide this again. So this is going to be 2 minus 2x squared. So this is going to be 2x squared divided by this. So this 2x squared will divide this, I mean, so we'll end up having minus 1 there because of this negative, and then this negative 1 multiplies everything. We'll have minus 2x squared minus 1, and then we'll put the negative thing there outside the thing, outside the bracket, and then we add these terms here and these terms here. So we're going to add these terms and these terms, so we're going to have minus 2x squared minus minus is going to be plus, so we're going to have 0x squared plus 1, so we're going to have 1 here, you understand? So as our remainder, so meaning that the integral of this, so integral of 2x to the power 4 minus x squared is the same, divided by 2x squared plus 1. The x is equivalent to the integral of what? Of a remainder over the divisor. So it's going to be 1 over 2x squared. So it's going to be 1 over 2x squared plus 1. The x plus the quotient. So okay, let me just do this. So plus the quotient there is going to be x squared minus 1 and then dx. So instead of integrating this, then we'll then integrate this, because of we just rewrote this quotient using long division method, and then it became this format. Makes sense, right? Then from there we will then split. So we're going to split here. We're going to split, so we'll have the integral of what? Of 1, of course, divided by, okay, so we're going to write 2x squared, rewrite 2x squared in a nice format as well. We're going to write it in square root of 2 multiplied by x, and then squared plus 1 dx. So what I did there, I rewrote this 2x squared plus 1 in a nice format. You understand what I did there? So that we can see that it's a tan inverse. You understand? So, and then here, this is just going to be integral of x squared minus 1 dx. So to integrate this, okay, before here we can already see, of course, that the shape, this format is that one of tan inverse, but we need to, before we conclude, we need to first make sure that on the numerator we have the derivative of this f of x. So when we derivate this square root of 2 multiplied by x, we get the square root of 2. So here I should have a square root of 2, but then because of I didn't have that square root, I should cancel it out by putting 1 over square root of 2 outside the bracket, and then from here I can make some conclusions. So I can say that this will then be equivalent to, so I'm going to take the 1 over root 2 out to my answer. Then because of I have a here, I don't have to write 1 over 1 outside there, so I can just write tan inverse of what, of just root 2 of x, then plus I integrate x squared, that's just going to be x cubed over 3 minus x plus c, then ta-da, I have my answer. So that's just it, so you don't need to stress about these ones. So yeah, I hope you got it. They were easy. So yeah, let's check if we can integrate something else down there. Now let's just quickly do some of the definite integrals. So let's see if we have some definite integrals here. Yes, we do have some definite integrals. So let's check them out. Okay, let's check these definite integrals out and then we'll be done for integration of inverse trigonometric functions. So let's just do 2-3 examples or 3 questions under this. So remember to pause the video, guys, so that you can work out on these problems on your own and then resume later to check the memo. So yeah, now we've got the integral of 1 dx divided by x squared plus 4. So what's going to happen here is that you need to do this. You need to rewrite it nicely first so that you can see that indeed it is what you are dealing with. So I'm going to rewrite it nicely because I don't want to get chopped by easy equations because of being lazy to write it nicely first. So here I can see that I have my x squared plus 2 squared dx, and then on my numerator I have 1. So I can see that already this shape is that one of what, of tan inverse, right? So I need to do what? I need to just make sure that I have the derivative of x on my numerator there. So when I differentiate x, I get 1, so I don't have to stress. So also because of my a here is equivalent to 2, so I know that whatever that I'm dealing with is that formula of 1 over 2, okay, or 1 over a, my a being 2, tan inverse of what? Of x over 2, and then I put my limits, the limits being 2 and minus 2, and then yeah, from there you just substitute. So I'm going to substitute there. The limits is going to be 1 over 2 tan inverse of 2 over 2 minus 1 over 2 tan inverse of minus 2 over 2. Then you should get something like what I'm gonna get here. So this is going to be 1 over 2. So this I'm busy pressing on the calculator, so please be with me there, be patient with me as I press these things. 0.5 shift tan inverse of 1 minus 0.5 shift tan inverse of 1, negative 1, I mean. Yeah, you should get something like pi over 4 on your answer. So this should be the correct answer. So provided that you didn't make a mistake, of course, you should have gotten to that answer that I've gotten to. Yeah, and then now we have another one here. We have another one. So this is going to be what? Because of, we can already say that this format of 1 minus that thing is the one for sine, right? It's the one for sine. So we're going to we know that we're working with sine inverse. The only thing that we need to do is to rewrite this firstly in a nice way. So we're gonna write our pi over 8, 0, we have 1 here, and then what? We have square root of 1 minus 2t squared dt. So now we're integrating with respect to t. So we can already say that this format of having something like a squared minus f of x squared is that one of sine inverse. So what we need to make sure is that we have the derivative of what? Of this 2t on our numerator. So when we differentiate 2t, what do we get? We get a 2, right? So I can just erase this 2, a 1, and write a 2. But because if I didn't have 2, I need to cancel out the 2 by putting out 1 over 2 there. And then at the end of the day, I'll have, I can then conclude that this is equivalent to 1 over 2 sine inverse of just 2t. 2t. Yeah, just 2t. And then I put my limits being pi over 8 and 0, and then that will be just it. And then we substitute the limits. Now we're going to get 1 over 2 sine inverse of 2 multiplied by pi over 8 minus 1 over 2 sine inverse of 2 multiplied by 0. So we then use our calculator, or if your brain can solve such things, you can just use your brain. So we're not gonna limit you. I'm gonna use my calculator because I don't think this brain can calculate things like this. Oh, basically, I don't think, I know this brain. I get it to my brain. I know that this brain, this one is not, make sure it can't solve those things. So you will then use your your calculator then, if you are like me. So you should get something like 0. You should get something like 0, 452 as your answer there. So yeah, this should be your answer when you use your calculator there. So yeah, I hope you got it. It was an easy one. Okay, now let's also see this one. Let's see this one. Let's see this one. So now we've got ourselves this definite integral as well, whereby we're supposed to integrate the sine of 2x divided by what? Divided by 1 plus sine to the power 4 of x dx. So what we need to do first is to rewrite this in a nice way first before we could do anything to it. So let's start by rewriting it first. Means that we are going to say pi over 4, 0. So we know that sine 2x is the same as 2 sine x cos x, right? So okay, I don't have to rewrite that. I don't know if I should, but let me just leave it like that. Sine of 2x, let me just leave it like that. I hope you all can see what's happening already. I hope y'all can see what's happening already. So this is going to be sine squared of, let me write this like this so that I don't face troubles, because sometimes I can also get chopped, but hardly. Okay. Now I've just successfully managed to rewrite this in a nice way, that could be interpreted nicely. So I can see that this format is the one for tan inverse, right? Because of I have 1 plus this squared, right? Makes sense. So I can see that if I let sine x squared to be my f of x, then the derivative of it, I need to use chain rule. So it's going to be 2 sine of x multiplied by the derivative of sine x is going to be cos of x, which is and then this is the same as 2 sine of 2x, right? So that means the thing that I have here on my numerator is the derivative of this thing. So if I have my f of x here and the derivative of it on the numerator, and this is in this format of tan inverse, then I can conclude that the thing that was differentiated here is the tan inverse. Also, because of my a here is equivalent to 1, so I don't have to have 1 over a blah blah blah, because my a's will be 1. So I can just say the thing that was differentiated here is tan inverse of what? Of sine squared of x. Then I put my limits, the limits being from pi over 4 to 0. Then I substitute my limits now. This is going to be tan inverse of sine squared of pi over 4 and then minus the tan inverse of what? Of sine squared of 0. And then from there you're going to substitute. So you're going to substitute the limits there. So you're going to substitute your limits, and then you'll find that this is shift tan. So now I'm punching on my calculator. If you're wondering what is this guy doing, I'm punching on my calculator. So please be patient with me. I'm also punching on my calculator. I am doing these things as I do this video. I didn't practice this problem, so otherwise if I practice, then I would have written the solution next to or somewhere. I would be just copying, but I didn't want to copy. I also wanted to take it out from my brain. I wanted to see if this brain could solve these things. So yeah, I have sine squared. I'm done punching now. So the answer that I get is 0, 464 0, 464. So yeah, that should be your final answer for that thing. So you should have gotten the same thing. Otherwise, if it's a different thing, it's wrong. So yeah, that's just it. I hope you are pausing the video to do these things on your own there, because that's a very good way of practicing. You can't just be watching this thing like you're watching a movie. So there are time for movies, time for lessons, guys. This is a lesson, so please be practicing there as well. So we've got another guy here. We can see also this one is for a tan inverse, right? Because of we have 5 plus this. So whenever we have plus 5 plus something squared, then it's the one of tan inverse. So what do we then do? We need to first rewrite it in a nice way before we make some conclusions. So this is going to be this. I'm going to take the x up because of I can see that already 1 over x was differentiated ln of x was differentiated. So we'll have square root of 5 square root of 5 square root of 5 squared plus ln of x squared dx. So I can see that, okay, now I've successfully managed to rewrite everything in this format. So I took out the x up there. I took it up, so it became 1 over x up there, and then now I rewrote 5 in terms of what squared, so it became square root of 5 squared, and then rewrote ln of squared to be like in this format, so that we can all see that this is tan inverse because of we have a squared plus f of x squared on our numerator having the derivative of f of x. So when we differentiate, if we let f of x to be our f of x, if we let ln of x to be our f of x, then the numerator here is going to be the derivative of this. which satisfies our formula for tan inverse. You understand? So then we can conclude that the thing that was differentiated here is going to be 1 over a, because of our a here is not equivalent to 1, so it's going to be 1 over square root of 5 multiplied by the tan inverse of what? Of ln of x. And then you put your limits being 3 and e, and then we substitute the limits. Now this is going to be 1 over square root of 5 multiplied by the tan inverse of what? Of ln of 3. You close minus 1 over square root of 5 multiplied by tan inverse of ln of e. So from here we're going to use our calculators, or if your brain is capable, you can also use your brain, guys. I'm not going to limit anyone here. If you know that your brain can do this, please do it. Please do it. Some brains are too much, so we don't want to limit those brains that are too much here. So please flex there, flex. Let's see your brain. Let's see what your brain can do. Let's see what your brain can do. Square root of 5 multiplied by shift tan inverse of 1. So I'm down pressing on my calculator. I'm getting something like 0, okay, let me just verify. So tan inverse of, okay, let me write ln of e. Okay, so I'm getting 0. Oh, my bad. So guys, I did a mistake. Now I can see. Shit. Oh, just a minor mistake, guys. So here I didn't divide by the a here. So I didn't divide this argument by a, and it's making me to get a different answer. I'm very sorry. I must be tired. I must be tired. I'm realizing now when I'm supposed to get the answer that this answer doesn't make sense. So this is going to be ln of 3 divided by 5. Ln of 3 divided by 5 ln of e divided by square root of 5. I'm sorry, I'm very sorry, guys, for that. It's just a minor mistake. I've been solving complex thing up there, so you can see that this guy must be tired. So I'm sorry though. It's I'm very sorry. You know, maths is like this, guys. Everyone like makes mistakes, and that mistake make you to get chopped, you know. So I got chopped there as well. So I don't know, justice for me, guys, justice for me. Maths is doing some things to me. So yeah, let's see what I can get if I fix that. So yeah, you should be able to get something like 0,016 as your answer there. Yeah. So yeah, that's supposed to be the correct answer for that question. So yeah, I hope you got the same thing as well. Yeah, please avoid the mistake that I did of forgetting to divide by 1 over a here on your argument. So yeah, it's just a minor mistake. The brain was thinking of things there that I don't know. How can you make a mistake, man? Pella, you are making a video here. You can't be making mistakes. We're trying to learn from you, bruh. But you are making mistakes. It's just, I'm sorry. All right, guys, let's continue. Two more last questions, then we're done with this video. So including this one, it's 2, yes. So yes, we can see this one is also a tan inverse. They like tan inverse. Whoever was putting these questions like tan inverse, because you can see already we have a plus here. So whenever you have a plus, you should always think of tan inverse. So this is going to be, so what I'm trying to do here is to rewrite this in a nice format first. So I'm going to get 2 squared plus 3e to the power of x. Nyenzani. So it's not gonna be tan inverse, guys. It's not gonna be tan inverse. I'm realizing that here we don't have e to the power 2x, so it's not gonna be tan inverse. Yo. So yeah, it's not gonna be tan inverse because of what? Because of we don't have e to the power 2x here. So yeah, let's just solve it using another approach. So what we're gonna do is that we are going to instead let this whole thing on the numerator to be my f of x. So if I let 4 plus 9e to the power x to be my f of x, so meaning that now I'm trying to force the general log rule, you understand? So I see when I differentiate it, I will get 9e to the power x, but I don't have a 9 there, so I must put a 9 and then 1 over 9 here, you understand? So now that I have the derivative of the denominator on my numerator and my denominator here is an exponent of 1, meaning that I can be allowed to use the general log rule. So I'll take the 1 over 9 with me to my answer, and then I say this is equivalent to natural log of 4 plus 9e to the power of x, and then I put my limits being 1 and 0, and then I substitute my limits from there. This is going to be equivalent to 1 over 9 the natural log of 4 plus 9e to the power of x minus 1 over 9 the natural log of 4 plus I didn't substitute the limit of 1. Sorry. I'm seeing that. What am I doing now? Is it because of 2 last questions that are left? So it means that I should make mistakes? Doesn't make sense. So yeah, then from there, we are then going to use our calculators. We should get something like what I'm going to get here. Otherwise, if you get something else, it means that you have done something wrong. Plus 9 e minus 1 over 9 ln of 4 plus 9 e to the power of 0 Okay, I'm just confirming my answer on my calculator. So just a second, please be there with me. My calculator is giving me things that I doubt they might be correct. So let me just punch it manually on the calculator and see that okay, 0, 0,087, 0, 0,087. So just a second, guys, just a second. I will be there with you. I'm just confirming my answer here. 4 plus 9, this. Okay, 0 and 1. I should get 0, 0,087. Okay, just a second. My calculator is still loading. Oh, I'm trying to just integrate using the calculator. So yeah, I am getting 0, 0,087. So yeah, this should be the correct answer for your thing there. 0, 0,087 should be your correct answer for that question. So you should have gotten 0, 0,087 as well. So here right now we are going to have this one. The last one. So please be patient. Okay, we can already say that is the one for sine, right? Is the one for sine inverse because of we have a minus something squared there. So this, we need to first just rewrite this nicely, put the limits. So this is going to be 1 minus 1, and then now I'm trying to rewrite nicely. This is going to be cosec of x, cot of x divided by what? So I'm going to write that 3 in terms of what squared. So this is going to be square root of 3 squared minus cosec of x squared. Okay, so when I check this thing, so now I've just successfully managed to rewrite everything in this nice format. So I can see that this is the format of sine inverse because of a square root of a squared minus f of x squared. So if I let cosec to be my f of x, in the numerator I should have the derivative of cosec. So when I know that when I differentiate cosec, what do I get? I get negative cosec cot. So meaning that here they should be negative here, you understand? And because of I didn't have this negative, I should then put another negative outside the integral. Makes sense? So if I have the derivative of the f of x, then I need to then just conclude, then you should take this negative with you to your answer. This is going to be negative sine inverse of what? Of cosec, right? Of cosec of x. So this is going to be CSC of x, and then you put your limits being 1 and minus 1. So because of we can't be able to punch cosec in our calculator, we can just convert it to its equivalence when it comes to the reciprocals. So I'm going to then just say this answer is the same as negative sine inverse of 1 over sine, right? So 1 over sine. So this is what going to be equivalent to 1 over sine of x. And then I put my limits being 1 and minus 1. Then from there, I'm going to substitute my limits. So this is going to be sine inverse of 1 over sine of what? Of 1 minus into sine inverse of 1 over sine of negative 1. Then you close again. Then you punch on your calculator, or if you have that brain, you can also just use your brain. We're not going to limit you. So yeah, let's punch everything on the calculator. There I'm getting negative sine inverse of what? Of 1 over sine 1 plus sine inverse of 1 over sine 1. Another thing, you should make sure your calculator is in radians for you to be able to getting the answers that we'll be getting. So you will realize that this is going to give you something like maths error. So this is going to be maths error. So let me just validate this with the use of my calculator. So just be there with me for a second. So yeah, let me just validate this using the calculator. So just a second, guys, please be. Oh, is it a maths error or I didn't? Yeah, it is a maths error. It is maths error. So yeah, let me just use a calculator to verify if it's really a maths error. So let me just punch everything here on the calculator and see if I will get the maths error indeed. So cosec, it's 1 over sine of x. Sine of x. Cot, it's what? It's cos over sine. So okay, multiplied by cos of x divided by sine of x. So if I still get maths error with the use of a calculator, then we will then conclude that yeah, my answer is correct and maths error is the correct answer for this integral. Or the definite integral of this does not exist. That's what the maths error tells us. So 1 over sine of x squared. Put my limits. Negative 1 and 1. So this is going to be what? using my calculator. Yeah, I am getting maths error again. So maths error has to be the correct answer for this when you use the. So this everything here is correct. So yeah, that was it for this video. Hope you understood and you're gonna chop your exam. So good luck, and I'm gonna see you in the next video. Take care.